Hello everyone. So today we are discussing about the topic singly and doubly reinforced beam, and most importantly why we need a doubly reinforced beam. So that's the topic we are discussing about. So first we understand what is a singly reinforced beam and doubly reinforced beam. So the singly reinforced beam is nothing but a beam in which we provide the reinforcement in the tension side, and there is reinforcement in compression, but just for the purpose of holding these shear reinforcements together. So we have to hold this shear reinforcement too, otherwise during the vibrations there will be the movement of these shear reinforcements. So to hold these properly, so the compression or this holder longitudinal reinforcements act as a holder bars. So in this case the main role is played by the bottom or tension reinforcements. So in this case the upper portion or the this upper half portion acts as a portion which has to resist the compression, and the lower half has to resist the tension. So the compression is resisted by concrete, as we know that the concrete is a good material to resist the compression. However, it can't resist the tension. So the next one is this. So this is singly reinforced. This one is singly reinforced beam, and we have next one is a doubly reinforced. So for doubly reinforced we have the beam, and inside we have this frame. We put the longitudinal bars, and yes, in this case we have a reinforcement both in tension as well as a compression side. This is the doubly reinforced beam. So there are different circumstances when we have to use this doubly reinforced beam. So doubly reinforced beam, so we are going to discuss about the conditions when we use this doubly reinforced beam. So conditions why we use this doubly reinforced beam. So we have the first reason is that the if the area which we provide on the tension sides, that is the suppose we provide this reinforcement, and the area comes out to be, let's suppose the bottom reinforcement area comes out to be 650 mm square. However, the limiting area, that is the maximum amount of the steel that we can provide at the bottom reinforcement, is only 550 mm square. Then in such case the section ultimately has to resist the moment. However, we can't provide the steel reinforcement more than the 550. So in such case we provide the reinforcements at the upper half or in the compression zone, so that we could increase the moment resisting capacity of the section. So that is the main reason why we provide it. So the first reason is that we have to increase the moment resisting capacity. So to increase the moment resisting capacity of this section, moment resisting capacity of this section, and then the second one we provide is when the compression steel is provided, the failure mode changes from brittle failure of concrete to ductile failure or ductile ductile failure of steel. So in such case, in sometimes the concrete crosses before the yielding of the steel starts. So in such case, the situation is that during the earthquake, ductility requirement is very much important from the safety requirement also. So if the section is ductile, we could get enough time to escape away from the vulnerable building. So in the situation where compression still changes the failure mode from brittle, that is concrete crossing, to ductile failure, also the compression reinforcements are provided. So we can write compression steel changes the failure mode from brittle, that is concrete crossing, to ductile, that is steel yielding. And this is vital during the earthquake, that is this is vital for earthquake resistant buildings. And the third one is that it transfers the over reinforced to under reinforced section, that is it transforms an over reinforced to under reinforced section. So how this happens is that under reinforced to over reinforced section changes to under reinforced when we provide doubly reinforced, because initially when the section is over reinforced, in such case here the concrete crosses fall first. This concrete cross first, and the steel is not steel yielded. Steel does not yield. This happens in the over reinforced case. However, if we consider the under reinforced case, so in such case the steels are added on the compression. This one is for hanger bar, and this addition of extra steels, these are the extra steel. So when extra steel is added, it changes to under reinforced. But how this happens, you have to understand that when the extra steel is added, the compression side is able to withstand greater amount of stress due to the addition of these extra steels. So when the stress goes on increasing, so the first the mm, yielding happens to on the tensile steels. It is because the moment resisting capacity of the compression zone is generally increased due to the addition of the reinforcement in the compression side. However, on the tensile side, the steels are still the same. So due to this reason, these still have to still on the tensile side have to yield first before the yielding starts in the compression steels, or the before the crossing happens in the compression zone. So the addition of the extra steel makes the compression zone stronger, makes compression zone able to withstand greater stress, able to withstand more stress. So during the yieldings, the tensile stress yield first. So this situation is the under reinforced case. This is the under reinforced case. And the next one is why we provide doubly reinforced is that it increases the amount of curvature that a member can take. So increases the amount of curvature that a member can take before failure in flexure. And other reason why we provide the doubly reinforced is that the compression steel is effective in reducing long-term deflection due to shrinkage and creep. So it reduces, or it is effective in reducing the long-term deflection. So it reduces long-term deflection due to shrinkage and creep. So shrinkage happens after the concrete is casted, and the creep also happens. It means a deflection occurs under the constant load. So in such case, also the doubly reinforced is more effective. And the other reasons is that when the dimensions of the beam is restricted due to the architectural requirement, in such cases also we have to provide the doubly reinforced beam so as to increase the moment resisting capacity. So dimensions of the beam are restricted due to architectural purpose. Beam are restricted due to architectural requirements. So suppose the beam is beam is 400 mm by 300 mm 300 mm 400 to 300 mm. So in such case, suppose that the architectural requirement restricts the depth of the beam to 300 by 300 mm. In such case, if you have to get the same moment resisting capacity but the depth of the beam has to be restricted or reduced, in such case we can provide the doubly reinforced beam here. We can provide doubly reinforced beam here, not here, but we can provide doubly reinforced beam here and increase the moment resisting capacity. So yeah, addition of extra steel increases the moment resisting capacity. This is the case. So, and the seventh reason why we provide is the in the case of the continuous beams also, where the bending moment changes the sign due to the moving loads in the bridge, or in the case of the lateral loads like wind or earthquake also, we have to provide the doubly reinforced beam so as to resist the positive as well as the negative moments due to the stress reversal or change of the loads continuously due to the moving load. So we provide this in the case of the stress reversal or we can say it is in the case of the continuous beam, in the continuous beam due to moving load, beam due to moving load, such as bridge, or in the case of lateral loads like winds. And the eighth reason is that it acts as a holder. It means that compression still acts as a frame to hold the shear reinforcement. So this means that compression steels acts as a frame to hold shear reinforcement. Shear stirrups, yes. So yeah, when we provide this compression reinforcement, the shear reinforcement can stand well in its position, and the movement of this shear reinforcement is not easily moved here and there during the concrete vibration, when concrete casting. So it should not move. It doesn't move during concrete casting. Shear reinforcement doesn't move during concrete casting and vibration. So these are the 8 reasons. So we're going to repeat it. So the first one is that to increase the moment resisting capacity. Yeah, ultimately it is required to increase the moment resisting capacity due to restriction of steels in tension zone. Due to restriction in the amount of steel in tension. Restriction in steel area of steel. So it is generally in the tensile zone. So the second one is compression still changes the mode of failure from brittle failure to ductile failure. So this is vital during the earthquake, and we easily understood that the it transfers the over reinforced section to under reinforced section. So this one we discussed well earlier, and it also increases the amount of curvature. So this is generally important during the earthquake. So the beam curls down like this, so it gives us a warning to evacuate from the building before the building collapses. So in this scenario, the uh, building is not going to building is going to collapse, but in such case you can run away from the building. So this is required for safety purpose. And the next one is, it is effective in reducing long term deflection due to shrinkage and creep. And the other is dimensions of the beam restricted due to architectural requirement. In such case also you have to provide the doubly reinforced beam to increase the moment resisting capacity. And in the case of the continuous beam such as bridge, and in the case of where lateral loads are exerted such as wind loads, so in such case also we have to provide the doubly reinforced beam. And the last one is, it acts as a holder to hold the compression. So it acts as a holder to hold the shear reinforcement. So compression still has these 8 roles, and you can write it in any kind of examinations if it asks. So thanks everyone for watching my video, and if you feel that this information is suitable, you can subscribe and like my channel for more updates. I will be uploading if you require such videos. Please comment also.